Hello once again, my name is Tomasz Gebarowski and I work as an iOS developer at mBank, but today's presentation is going to be not about iOS. I'm going to talk about Git. Git in case of larger repositories which are maintained sometimes for years or where the maintenance time is simply unlimited. So let's get started. The agenda of today's presentation is as follows. First, I will talk about clean Git history. What are the benefits of having clean Git history? What are the problems in achieving it? And how to move from having clean history to regression tracking, which is, I think, quite important when you have large code base. When you have lots of merge requests and when the code base changes and the regression risk is quite high. So then I will move on to something else, which is branch management and working with Git flow and the typical problems I am observing quite frequently when I'm joining some new projects, where people say that Git flow is used, but in fact they are violating some basic rules of Git flow, or there are some problems because some rules are not followed. And finally, I will move on to something that I hope is quite not known by many of the developers, which is working with several work trees in Git. Some feature that I haven't known, and I hope that most of you don't know that feature. So let's get started with clean Git history. Okay, so we all probably work in some kind of variation of Git flow, and usually our flow is similar to the one that is depicted on this diagram. So we are either creating a fork branch from develop when we are working on a feature, or we are creating a branch from release to make some bug fix, for example. And we are then proceeding to making some commits, usually in some kind of sequence. Some commits are treated as snapshot commits. Probably there are some kind of work in progress commits. And then we publish this work making some kind of pull request. And the pull request is evaluated by some developers. And after that, upon receiving some positive or negative feedback from the developers, the commit is merged into develop or some release branch. And when it comes to merging, we have, two possibilities. Of course, we can also merge through rebase, but I'm going to talk about most popular ways of merging. We have like merge with fast forward, which is default for Git command line and which simply prefers moving the head pointer so that if it's possible, if the branch that is the source branch, that the origin from the branch we forked off hasn't diverged, then the fast forward is possible, and simply the fast forward the head pointer is moved and no merge commit is created. So basically the history is flattened in this case. And on the other hand, we have merge without fast forward, which is simply made using the flag no fast forward. And in this case, we are simply forcing merge commit. So each time, no matter if the origin of the source branch from which we branched off hasn't changed, we are simply creating a merge commit. And the merge commit is some kind of empty commit that simply connects to parents, parent 1 and parent 2. And parent 1 is usually the branch that was the branch from which we branched off, and parent 2 is the end of the branch we are merging into. So we have merge commit. And this merge commit resolves some conflicts, for example, and it's simply like the commit that connects two branches. And now the question is whether we should fast forward or not. First of all, when we fast forward, then this kind of commits are usually hard to revert because we are flattening the history, and if we are not squashing these commits and they are like simply the history is flattened, then those commits can't be reverted. So if they can't be reverted, then it's quite hard to, for example, get rid of some regression that was introduced. If we are not marking those commits somehow with some tokens, then anyway we have to revert them one by one. So this is some kind of disadvantage of having fast forward. And of course the history is linear, so we are losing the information about the branches, the branch that was started, from which we started, for example. But wait, linear history is not always bad. Because with linear history, it's easier to scan this history. So basically, we can easier bisect the history. We can easier blame for the changes. We can simply easier scan it in search of some commit that introduced some problem. So there is also option number 3, which is rebasing before merging with no fast forward. And when we rebase before making merge with no fast forward option, then we are simply having some kind of branching history as on the right. So it's more resembles the flat history, which is easier to scan, where, for example, git bisect behaves, well, it's easier to follow. So what are the problems of having rebase before merging with no fast forward? First of all, basically the conflicts that are going to be resolved are a bit harder, because when we are rebasing, then we have to resolve them for individual commits. And in case of normal merge, we are resolving conflicts only once in the end. And because we are rebasing, we are changing the hashes of all the commits that are added on top of the new base. So this can be some kind of disadvantage. And of course, it's another step, so it takes time. So I prefer to rebase before merging, but to keep the history in order. But it's like a matter of each maintainer. It's like the preference of the maintainer of the branch, if they prefer to make rebase. And let's go back to our example. When let us assume that we are working on some kind of feature, and usually from my experience, what I observe is that developers are making lots of commits, and they are adding them into pull requests, and those commits can be divided into several groups. First of all, we have commits that are work in progress commits. So they are treated like some kind of snapshot commits, just for backup, so that developers, they are pushing them just in case something happened to their computer. They treat them as backups, and later they forget to squash them, or they simply don't know how to squash them, or I don't know. There are different stories, but it's quite frequent that there are work in progress commits. Maybe they are not named directly work in progress, but in the end, when you check out on that commit, it's definitely sure that it has some kind of work in progress state. Then we have another type of commits that are simply the commits that are fixing something that was added before, and there are some probably intermediate commits in between. So this is quite, this is like usually a bad experience for the reviewer, because when the reviewer is doing the review based on the commits, he starts to review, for example, the first commit, then he made some notes, and then 3 commits later, he can notice that this was totally changed, and he's like a bit confused. So it's simply a waste of time of the reviewer. And we have also commits that are like totally not related to what is going to be fixed. So those are the commits that are basically added there by accident, or the commits that are simply introduced when, or the changes that are introduced when someone, for example, uses -a flag, where he simply adds everything. and he's not verifying what's going into the commit. And now the question is, why the snapshot commits are bad? They are bad because they usually quite frequently break the build. When we make some snapshot commits, we are not testing them, and they break the build. And when they break the build, then when, for example, git bisect stops at those commits, they are not possible to verify whether they introduced some regression or not. Frequently, they are not passing unit tests, because on individual commits, we are not running unit tests. So this is also something that is, well, not that welcome in case of using, for example, git bisect. And the last but not least is that they create some kind of line noise. So the line noise is when one commit is fixing another commit and there are some commits in between. So this is line noise, and this is also not very nice to have in Git history. And why do we make them? We make them because they are we are lazy probably. We don't want to, we simply commit, we don't care, we make some snapshot commits, we need some checkpoints in our code to which later we can go back. And sometimes we make them because we are fixing something that was revealed in the code review. So those types of commits are added after the code review, and they usually got merged into develop. So this is something that is really not nice to have when you have the whole history that is merged, the whole history that is quite messy, that is later merged into develop. And I think that it can have some impact on, for example, on your later performance when you have to later go back and scan the history in search of some kind of problem that appeared, or some regression, or, for example, when you simply want to see what the developer had in mind when implementing some feature. So what are the options? First, we have the first option is keeping the regular history. So we simply don't care. We are a startup. Our project is a short-living project. We want to deliver fast. And when we want to deliver fast, we don't care about the history, because simply we have time limitation and we don't care. And on the other hand, we have clean history, following some rules that I will describe in order to make it cleaner. So let us assume that we won't be clean. So let's be clean. And in fact, working with following some clean history rules is quite simple. First of all, we are distinguishing two types of branches. We have public branches, which are supposed to be immutable, where we can't rewrite history. So those are the branches that, according to Git flow, it can be master, develop, some kind of release branches, some hotfix branches probably. And those branches are immutable, so we can't rewrite history. So we can't, cherry picking is not that welcome between those branches, for example. Only in case, for example, of backporting. So those are the branches that has to follow for example, the golden rule of rebasing. And then we have private branches. And the private branches are all the branches that we have in local repositories. So those branches are treated as scratchpads. So when we treat them as scratchpads, we can rewrite the history there. Of course, this kind of process has to follow the golden rule of rebasing. So simply, we are not rewriting the history of something that is already in public branch, because it will break the history for other developers. But for all other cases, we can do whatever we want with this history. It's totally safe. So we can, for example, cherry pick, we can delete some commits, squash them, edit, amend, make some fix-ups. And you may ask, history rewrite. Yes, I'm I'm talking about history rewrite, and it's totally safe when you follow the golden rule of rebasing, which is not touching the code that is already in public repositories. So what are the history rewrite tips? Well, first of all, when I'm speaking about the history rewrite, I'm speaking of git rebase in interactive mode. So basically, you can invoke git rebase in interactive mode using using one of the two following syntaxes. The first one simply goes back and commits from the head, and then you are going to rewrite only the last n commits. And the other is like you can access the hash. You are referring to the hash, which is the hash before the commit you want to rewrite. So let us assume that we are going to rebase the last 6 commits from head. The head pointer is set at the bottom commit, and the top commit is the last commit from our history. I hope that you more or less know this screen, and it's just a matter of reminder. But just in case, I will explain the options, which are P stands for pick, and you can like leave this comment as is, or you can simply change the order of them by changing the lines in this file. Then you can reward, so it's just a way of changing the commit description. You can edit the commit, so it means that you will stop the rebasing process in order to amend and either extract something from the commit, delete something, modify, append. So you are just playing with the content of the commit. Then we have fix up, which I will describe on the next slide, and execute, which simply runs some kind of command, which is run every rebase, and you can, I don't know, test something that is scripted. And D stands for drop, so you are basically dropping the commit. And also when you just delete the line, it will be the same. So let's start with something that I hope you don't know. It's squashing with fix-up annotation. So I think that it's best to explain that on some example when, for example, it's quite frequent. When you are working on some feature, release, bug fix, or whatever. You are working in some kind of sequence of commits. You are fixing something related to module B. You are committing that under a commit that is described, for example, adding feature A in something. Then you are in the same branch, you are working on something related to that, but something that you want to have in another commit. You're adding it, then probably you are adding something else, and then you realize that something that was implemented in the first commit is totally wrong. So you can easily fix it up by creating another commit that is prefixed with fix-up exclamation mark annotation. And with that, when you simply, I don't know if you can see it, it's like the first commit, fix-up exclamation mark adding feature B in file 1. When you prefix the commit in such a way, and later invoke git rebase in interactive mode with option auto squash, then this commit will be simply fixed up. It will be like ordered in a correct way, and it will be squashed with the commit you are amending. So it's quite convenient because you are simply appending something to the commit that was already added some time ago. And I use it quite frequently because, like, from the reviewer point of view, it's quite nice to have everything related to a given context in one commit, because especially when you are fixing some kind of logic, because it's simply easier to review. It's not wasting the time of the reviewer to check something twice because you decided to modify some logic in between. And then there is something that is also quite important with merge commits. When you are rebasing and by accident the scope of the rebase covers some kind of commit that is merge commit, and when you forget to use the preserve merges flag, then this history will be flattened, and probably it's not what you need. So using -p option for amending merge commits or for rebasing is quite safe because you are not flattening this information. Okay, now let's say a few words about reverting merge commits. As I mentioned, when we are fast forwarding, those types of commits are hard to revert because they are not annotated by anything. You have to call the git revert on every commit, or you have to script it some way. But when you have merge commits, then you can simply use git revert -m, then give the hash of the merge commit. And this magic number 1 stands for the parent 1 to which you want to go back in history, because merge commit has two parents, parent 1 and parent 2. Parent 1 is the commit from which you branched off, or the last merge commit that to which the information was onto which the information was merged. And when you revert this kind of merge commit, I don't know if you can see it, probably not. It simply creates a new commit, which is the cancellation of the changes in all the merge commits, in all the commits under the merge commit. So it's just a single commit, but it's quite interesting to know that later, when you want to merge this change once again, you have to, it won't be accepted because Git treats this change as already merged. So you have to rebase your merge commit or change the history in order to merge it once again. So after reverting, you can't merge directly the same branch. And now let's say a couple of words about showing the differences before the rebase and after the rebase. Because when you are rebasing, for example, it's a good case for changing the history after the code review. So, for example, you get some feedback from the reviewer. You want to apply it directly in the commits that you submitted to him so that there is no new commit that creates some kind of noise in the history. So the problem is how to demonstrate later the reviewer the changes after rebase. So you can tag the state of your code before the rebase and send the reviewer the tag so that later he can just diff the tag and the current state of head of the branch where the changes in the rebase process were made. And you are lucky if you tagged it before rebase. If not, then you can always tag the remote, which probably was not yet overwritten. If it was, then probably you have to find the hash in reflog before the rebase to tag it. But it's possible, and then the reviewer can simply get the tag and compare the changes before and after rebase. Okay, to sum up, the pitfalls of clean history and all this rebase process is that we may have some conflicts when we are rebasing, when we are changing the order of commits, when we're playing with the history. We may have some conflicts within the history. It's worth to know that there may be some conflicts. Sometimes it's a matter of sometimes it's not worth investing time in resolving some heart of conflicts. But I think that when you think about having clean history in advance, then those conflicts are harder to have during this process. And of course, it takes time. So this is just a matter of the politics of the maintainer, whether it's worth to spend an extra time to invest in this clean log history. And the benefits are, I think that there are more benefits than the disadvantages. First of all, I think that when you have nice Git commits and the history is well maintained, then you can treat it in some kind of as some kind of code documentation. Because when you document the code inside the code, then you are quite frequently forgetting to update those comments and you are simply get out of sync with what's in the code and in the comment. It's quite frequent that people forget to update the comments. And when you treat somehow Git history as your source code, a way of documenting source code, then when you blame something or when you display some information which is stored in Git log, it's always up to date because it updates with the source code. So when you treat the Git log and Git history as a way to document the source code, when you are simply not adding working progress commit on something, commits that are saying, I don't know, fixing and nothing else, then this kind of information is totally useless for any future maintainer or developer who's going to work with your changes. So I think that working with Git in aspects of cleaning the Git history is quite interesting idea, and it's probably worth investing time. And of course, it will help simplify the work of the reviewer. It will help with regression tracking using, for example, Git bisect. Okay, so when we're in the topic of regression tracking, let's say a few words about regression tracking with Git bisect. Git bisect is some kind of tool that is embedded in Git command line that you can run in order to search and trace regressions that were introduced in your code. And with Git bisect, it simply works as a binary search algorithm. So it divides a range into half, then depending on the test results, scans either the top or low part of the range. And let us assume that we are having some kind of regression that we want to track. Then we are simply invoking the Git bisect with the Git bisect start. And after that, we are indicating the bad commit in which we can observe the regression. In this case, when we invoke Git bisect bad, it will automatically assume that the regression is at current state of head. And then we have to Git bisect good to indicate the commit which contains good version where the condition simply passes. And after that, Git estimates more or less the number of checks that we have to perform. And the checks can be performed either manually or in some kind of scripted way. And on every check, we are simply marking the commit as bad or good. Let us assume that the commit and the head changes. Yes, the head pointer changes every iteration. And let us assume that we are testing something like in the middle of the Git history, and we are having some kind of test, and the result is bad. So with that, we can assume that all the commits from the top are bad, and Git does it automatically. And after that, the head pointer changes, and we are making another test, and let us assume that the test is good. Then finally, we can track the regression. And when we can track the regression, Git displays the first commit that introduced this regression. And in order to go back to the previous state, we have to reset the algorithm so that the head goes back to previous state. And the automatic regression tracking is totally possible. You can simply pass the script that is run every probe. And it can be some script that returns some value. 0 is to the shell. 0 is assumed as positive feedback. Non-zero value is assumed to be negative feedback. So for example, we have some kind of script that runs Xcode build and tests advanced unit test suite. Probably it's not like the best idea because this type of tests take some time, but on the other hand, when we have to, and we have continuous integration probably in most of the teams, so we can track those issues quite fast. But when the test is not covered by unit tests somehow, or it needs some kind of user interaction, then you can limit quite significantly the number of commits you have to analyze. And you, for example, have no idea which commit introduced this regression. Okay, so now let's move on to branch management, some tips and some typical problems I've experienced when maintaining Git repositories. So I hope that everyone knows this diagram and the link that is at the bottom. Well, in fact, it's a blog post that started the whole Git flow idea. It's called the successful Git branching model, and the guy behind this blog post, he described the way he thinks it's like the most convenient for him to work with Git branches. And it started the whole Git flow and the idea of having release, develop, master branches, and the way of merging them, and etc. I won't discuss it because I think that this article, this blog post describes it really in details, and it's a perfect place that covers most of the use cases and describes it quite well with all the diagrams. So let us move on to some cases that I meet quite frequently with working with Git flow, and by observing some developers and the errors they make quite frequently. It's the first one is when you are, I think that I have a bit different slides that I had, but I will tell you something about a thing that is not on these slides, but I had another slide that is probably on a different copy. Anyway, the typical scenario which I am observing is that you want to incorporate some bug fix that was made that affects several versions. And some developers are starting from develop as the starting point to branch off. And later, when we have to merge this into release branch, we are having problems because we either have to cherry pick and backport this, or simply there is no easier way to merge this kind of commits. And the golden rule of branching is that you should always branch off from the earliest branch to which you are sure that those changes will be incorporated. And then let's move on to another topic, that is comparing the differences between the branches. We assume that in case of Git flow, we have master, develop, release branches. And all those branches, they have to be somehow, the develop branch is the branch which has the biggest subset of the commits. The master branch is the branch that should be contained in develop because it has production ready code. The release branches are the branches that are like somehow contained in master in some point of time. And for example, in order to verify that Git flow is applied correctly, we can invoke git log with no merges option. And this command, well, when we compare develop with master, should always return empty list. So it means that master has no, maybe not always, but in most of the cases, should return an empty list because it indicates that master has no commits that are in develop. So master should have no commits that are in develop because master has production ready code which is already in should be already included in develop. Of course, there are some exceptions, but basically, when we quickly check the differences between develop and master, this command should return an empty list. So it means that there are no commits that were somehow incorporated in master and they are not in develop. And we can also compare this the other way around, so we can list the commits that are in master, that are in develop but not in master, so we simply change the order of this comparison. And this is quite nice to have for creating some kind of changelog when releasing some new versions. And of course, we can list those branches that were not yet incorporated to develop, for example, or remotes that were not yet merged with using this syntax. And the last thing, I think that it's quite probably one of the, for me, one of the preferences, because I meet it quite frequently. I would like to mention is that don't treat cherry pick as some kind of silver bullet. When you are cherry picking the changes, you are in fact creating new hash for this commit. So Git treats those commits as individual commits. And well, and it's not good because later when you want to merge the branches, you may have some duplicated commits or some conflicts because of that. So the question is, when to use cherry pick? I see only two cases where you could use cherry pick. The first one is when you have to backport some functionality, or backport some functionality or bug fixes. So when we have, for example, something that was fixed in a later version and you want to incorporate those changes in some older version, then there is no easy way to merge those changes, so you have to cherry pick them. And this is like the first case. And the other case is working with your local branches. When you have local branches, then you can cherry pick as you want, move the changes from one private branch to another, when you want to merge something that was started in another branch, and when you want to make those two changes as one pull request. So in this case, it's totally acceptable. In other cases, like moving the changes from release branch to develop, or some other cases where merge should be used, it's not quite nice to have. And now last is something that I hope that you don't know, is working with several work trees. So I think that there is quite typical situation which probably most of you had, is that you are working on some kind of nice feature and you are in the middle of the process, and then some manager comes and says there is a bug in production, or I don't know, there is some kind of critical situation which you have to solve. And you are assuming that you are like you have long compilation times, or I don't know, this test suite is running and you are in the middle of this process. You don't like the idea of interrupting it somehow. Or you have some changes which you don't want to squash, or I don't know, which simply are, you don't want to stash, or I don't know, you are in the middle of the process. And probably normally you would like have to stash, check out on the master, and I don't know, and start new branch, the hotfix branch. But with Git, it's now possible. It's quite new feature. I don't exactly remember when it was introduced, but I bet that it was like 1 year ago or something. No, not earlier. There is work tree command, which simply creates a new copy of your current work tree, checks out a given branch that tracks a given point in remote, and then you can move to this directory. You can work in that directory. You can commit anything you want. You can do all the changes that you would normally do in your repository. You can run you can even run the compilation. And then you can either push those changes to make another pull request, or you can easily go back to the directory, delete it, go back to the parent directory, delete it, and when you go back to the original directory, all the changes you made will be still in your Git history. So the branch you had, the commits you made, it works like that because the copied version simply treats this .git directory as some kind of symbolic link. So everything what you are doing in this copied version is affecting the history in the original directory from which you copied. Okay, so now let's move on to short demo. I prepared something to show you. Okay, so I'm here in some kind of dummy project that I prepared. Can you see it? Yeah, okay. And let's first test the work tree, how it behaves. So we are creating another work tree. It can be like, I don't know, if in some kind of directory, and it will, I think, trace, because it's like a local repository, so there is probably no origin. So, so I created another work tree, which is here in the parent directory. Here I can invoke like, I see some kind of history here. It points to the master that we are checked out at hotfix branch. And let us assume that I want to modify, create some kind of file here, which I want to add. I can commit it. Okay, it was added. It's in the history, adding dummy file. Now I can go back, remove the hotfix, go back to mobile Warsaw. Hotfix 2 is here with the dummy file change, yes? So it was synchronized somehow. So I think that it's quite convenient. And now let's move on to something else. I'm here on some branch that is a feature branch that is in quite a messy state. I have a work in progress commit here that simply adds some kind of calculated property. Then I have in another commit. Can you see that? Yeah, I think that. That you are simply adding more changes, and in fact you are adding a unit test to something that was introduced in work in progress commit. Then you are having some kind of other commits that are basically related to the second commit at birthday component user view model. So in the second commit after this adding birthday, we are like adding the birthday, the birthday field to the test case. Then we are modifying this test case, so it's like fixing another thing that was already back in the history. And then we are fixing some logic because we run the test and we realized that the test was failing because the condition was somehow wrong. So we are like changing something that in order to pass the unit test, and it's like in the new commit. And then we have some not needed commit, which is totally not related to what we are changing. So now let's start the history cleanup process. So we would like to go back to rewrite all the commits that we have here. So we have 1, 2, 3, 4, 5, 6 commits. So we can either say that we want to go back ~6, or we can like go indicate the first commit that is before the commit we want to change. So this commit is already annotated with the master, so the head points to this, the master branch points to this commit. So we can invoke git rebase in interactive mode, and we can say that we want to go back to the tag that is before the master. Vim opens, and what we would like to do is we would like to stop for editing the adding birthday component to extract the unit test that was accidentally added there, and you would like to append this unit test to work in progress commit. So we are annotating this commit as edit. Rebase stops. Then we can open, I prefer gitx, to change, amend the commit. This is the place we want to simply eliminate from adding birthday component commit, so I'm eliminating it. I'm committing like the amended changes. Then I have those changes which are still not staged. So I can fix up the commit that is annotated with work in progress. So I'm going to fix it up. In the history, it looks like, probably this history is not affected. So I simply introduced another commit, then I can rebase continue, just to show you what was the result. So I introduced the fix up work in progress commit on the top of the extracted change. And then I can invoke git rebase -i auto squash master, because I want to go, let us assume, to the same place. So the fix up commit was moved to be like near to the work in progress commit. It was like prefixed with fix up. When I save those changes and preview the history, I can see that the changes were amended to the work in progress commit. So they were like extracted from one commit and they were amended to work in progress commit. So I can do a couple of more tricks to clean this repository. I don't want auto squashing now. So I can reward this work in progress. Reward simply means changing the description. So I'm going to say that I am adding name field, let's say. It's like, okay. This was changed. And now I want to squash all these 4 commits into one, because they are like more or less related to some kind of operation related to birthday. So I'm once again rebasing to the same point. Of course, I can do more things at once, but this is something that, in order to show you the process step by step. So I'm simply squashing the commits, so I'm prefixing them with S. So this commit will be squashed into that, and into that. So in fact, it will result in 4 commits squashed into one. Now I'm seeing the description from all the commits. Let us assume that I want to have only the first description. Okay. It was squashed. So everything was squashed under this commit. And then I'm having another commit that is simply not needed here. Not needed commit. So I can delete this line. Yes, and the history was cleaned up. We have 2 commits that are simply representing what's really inside the commit, and it's a bit easy. Maybe in this example, because it was quite trivial example. So it was more to show you what you can do with history rewrite. But when you have like more complex scenarios, then it's worth to divide those commits in some kind of way that is later easier to review. Okay, so that would be everything.
Pokazałeś nam, co się dzieje, jak opis komita zaczyna się od fixa wykrzyknik.
Tak.
Czy to tak samo działa na pozostałe komendy base'a typu top, edit?
Nie sprawdzałem.
No to pewnie będzie 5 minut sprawdzenia w tą dokumentacji. Myślałem, że
Nie wiem, wiesz. No, po prostu znam fix-upa, bo fix-upa często korzystam, tak. To jest coś, o czym się dowiedziałem też od znajomego i wydawało mi się, że jest fajnie się tym podzielić, bo to często ułatwia sporo sytuacji.
Jak robisz git reset i masz taki case, że chcesz dodać test, który wiesz, że failuje, tak, a nie wiesz, w którym komicie zostało popsute. Po prostu brakowało ci testu, coś popsułeś, dopisujesz test i chciałbyś tym testem sprawdzać, to jest jakaś opcja, żeby ten kod sobie przekładać między bisectem, czyli masz lokalne zmiany, które są Ci potrzebne w czasie bisecta i jak to wtedy robisz?
Nie robiłem nigdy takiego scenariusza, więc nie wiem, no musiałbym poszukać, ale jakby nie wiem. Powiem Ci, że raczej chyba to nie jest wykonalne, ale no nie spotkałem się nigdy z czymś
Pewnie
takim.
można staszować,
No tak, pewnie można to jakoś oskrypcić też, tak, ale tak, no nie znam jakiegoś łatwego sposobu, który bym był w stanie Ci powiedzieć teraz, jak to działa.